Welcome to Division of Polynomials. This is being recorded in 2015 during a snow day. Hope you all having fun in the snow. Okay, so first of all, let's do some examples. If we have to divide 135 by 11, what is this? We could ask the calculator 135 divided by 11, and it gives us 12 point something or other. Well, what does that mean? Okay, that means we have 12 times 11 is going to give us 132, but 135 is going to have 3 more than that. So another way of expressing this is 12 remainder 3. Okay, or you could say 12 and 3 over 11. So those are all equivalent ways of expressing what's going on. So you can do this out by long division or use your calculator, whatever you like. Now what's going to happen is we're going to do the same thing with polynomials. Here, let me just give you one more quick example with numbers. Let's see, we have 2, 4, 6, 3, 9, 8 divided by 22 is equal to what? And again, I'm going to just figure it out using the calculator because it's faster. 2, 4, 6, 3, 9, 8 divided by 22, 11199. Okay. Remainder something. And how do I figure out the remainder? Well, I clear this out and I just take the integer 11199 times 22. And it's going to give me 2, 4, 6, 3, 7, 8. So it looks like it's off by 20. Okay, so, or you could say 11199 plus 20 over 22, which is typically written as 10 over 11 as a mixed fraction. Okay, so those are just some examples of what's going on. But what is it that we actually do when we're calculating it? Let's say if we were going to do it out longhand, the old-fashioned way, you get the first one like this, subtract, get 26, subtract, get 4, bring down the 3. You would like to put a 2 here, but unfortunately you can't. We almost could get a 2, but we can't. Bring down the 9. Okay, then 9 times 22, 198. And so you should get 21 again. And then you get 198, and you get 20. So you're going to get remainder 20. This process here, this awful process that we hated in elementary school, is coming back to haunt us. And this is division of polynomials. All right, case 1 is dividing by a single root. So the way this problem could look looks something like this. This is a single root. Even if the denominator looks something like this, let's say the denominator looks like this, this is tricky because this is really the following in disguise, right? It's just you need to factor out a 2, and then you'd have to put the 2 up here like that, or you could just, yeah. So even if you have a whole line on the bottom, it's really just a single root, and so we just adjust the problem. But let's not do any of those right now. Those are annoying. So let's go ahead and write this out as long division. However, we have a small problem. Notice that we don't have any x cubed part in our problem, and that's going to mess up our alignment. So if you're really, really careful, you could get away with it, but let's not risk it. Let's put a 0 there to hold the space so that we keep our polynomial all aligned, just like when we did long division for integers, we kept everything aligned using our digits, our place value. Okay? So now what's the question? Okay, let's see. How many times does x go into x to the fourth? Well, x cubed. So then we write this thing out, and then we subtract. But notice when we write subtraction for normal everyday problems, I erased it, sorry. We put a minus sign in front of an integer, but we can't put a minus sign here. What we really mean is minus this whole thing. So you can either flip the signs or put parentheses, but by some mechanism, some people just don't even write the minus and it's understood. By some mechanism, you have to remember to subtract from both columns. So it would help if this exponent were actually correct. Sorry about that. But anyway, these guys wipe out. You always make the first column wipe out. And so then you're left with your next work. Drop down the next piece, and then you ask the question, how many times does x go into minus 3x cubed? And the answer should be minus 3x squared. So then you go ahead and do this. Sorry, I'm sniffling. I don't know why that started. Okay, so minus 3x cubed minus 9x squared. Those go away because there's a minus sign there. And then this sign is going to flip, right? This is going to be minus a minus, so it's plus. So negative 10 plus 9 is giving me minus x squared. All right, now how many times does x go into minus x squared? Well, the answer should be minus x. And then you have minus x squared minus 3x. Again, this is going to flip the signs or somehow put a negative there. These guys are going to always cancel out. Remember, this sign changed, so you just have x now plus 4. That's good. I think that's good. X, okay, plus 1, so you get x plus 3. Again, you're subtracting. 4 minus 3 is 1, so you're going to get remainder 1. So that's the answer to that problem. And there's more than one way of writing that answer. Okay, I know that you can rewind the video, so I don't feel bad about cutting things off the screen like I do in class. Okay, so another way you could write this, instead of remainder 1, you could write it as plus 1 over x plus 3, and that's analogous. It's exactly what we did in grade school when we turned our remainder into a fraction. Okay? Okay, now that we have that technique, I'm going to just give you a little aside. I'm going to tell you, if you have 3x over x plus 1, first I'm going to show you what I would normally do. I would normally say, well, you know, this is 3x minus 3 plus 3 over x plus 1, and I would say 3, I meant to write plus and then minus, it just is easier. Then 3x plus 1 minus 3, this splits up into 2 fractions. And every time I do something like this, students get all frustrated because it's not something they learned in class, in high school. And so you know what? You don't actually have to perform that maneuver, because now that you have long division, you can just do this yourself. You just take long division. How many times does 3 go into x plus 1? Well, it's 3. Then you're going to say 3x plus 1 minus everything, and then you're going to get a minus 1 down here, so you can have a remainder. I'm sorry. I forgot to multiply 3 times 1. This should be a 3. Sorry. Okay, so then I'm going to have a remainder of minus 3, and I can write that as 3 minus 3 over x plus 1. Okay? So you can skip that little bit of algebra using long division. This is a structure you're already familiar with, and it's just a cute trick to have on hand. There are 2 different ways of getting to the same result. Okay, I paused so I could set this up without making you watch me. So let's say we have this mess here. This is our numerator and this is our denominator. So I've just set it up in this format, and I'm going to go ahead and ask the question, how many times does x go into x to the fifth? Okay, notice we're not taking into consideration the -1. We just worry about that downstream. So you just put the x to the fourth there, and then you multiply x to the fourth times x to the fourth times -1. Then we have to subtract this. These guys go away. Don't forget that sign changes, so it's 5 plus, -5 plus 1, so you get -4 x to the fourth plus 10x cubed. What I'm going to do is, if I were in class, I'd ask you to finish it. So I want you to pause right here, and then when you come back, continue from here. All right. So hopefully you paused and tried that yourself, and now you're going to watch me mess it up. Okay, so I want to know how many times x goes into -4x to the fourth, and I get -4x cubed, and -4x to the fourth, and I get a +4x cubed. Subtract this, these guys go away, this sign changes, 6x cubed. How many times does x go into 6x cubed? Well, these are pretty easy parts of the question. It's just keeping yourself from messing everything up, because this is so dreadfully boring that it's hard to keep yourself focused. I understand. I'm always messing these things up. But I want you to understand the structure. I need more space. So by the magic of computing, this one came out even. How cool is that? All right, we are golden on that one. So that means, oh great, yes, I have notes and it matches. Great. Okay, so here we go. What if you know that a function is 0 at a particular point c? So this is your x value. So this c could be 3 or 7 or whatever. How does this help? Well, we know c is a root even if f isn't a polynomial. Okay, but if it's a polynomial, then we can play magic. Okay, so for example, let's say we're asked to factor this. We know that if we put in x is equal to 1, this thing has a 0 here. So we already know this should have x minus 1 and then some other piece. It should come out perfectly, right? We don't know what that answer is, but this is 0 if x equals 1. So this piece is 0 if x equals 1 also, and then we don't expect that to happen on the other piece. So we go ahead and divide this. The only problem is, of course, we have to put in these extra 0 pieces, but we don't really mind doing that. It's a small price to pay for factoring a polynomial. Don't know why my computer is acting up. Okay, so let's go ahead and work this out. How many times does x go into x cubed? Well, that would be x squared. Scribbles. Okay, so then we get x squared plus 0x. I forgot to put the x there. And that goes, x times x is x squared minus x. Ding, scribble it out. Then you get x minus 1. Yay, it worked out. So the answer is x squared plus x plus 1. And notice that if I let x equal 1, this piece doesn't necessarily turn into 0. This was only required of the first root. We might get another copy of it, but the important part is there's just some other polynomial, and it works out perfectly fine. But the remainder has to be 0. It has to come out perfectly even in order for this trick to work. Oh yes, I do want to remind you that students often make the mistake if we know 0 if x equals 1, and then we try to put x plus 1 up here. That's not right. So you always have to think, what x is going to make this term turn to 0? And the answer is 1. So we say the root is 1, but we would say the factor is x minus 1. Okay? So just a little bit of terminology to be watchful of. And another thing is, even if you were to try to divide any polynomial by any factor, you get some junk up here, right? Your remainder is, let's say remainder 7. Then you knew that the polynomial, it's whatever number you want, polynomial, if you put in a 7, I'm sorry, if you put in C, the answer is 7. That's a little trick. And this is why if is 0 here, this is going to be 0 here. So this is always true. This is a little factoid you don't have to know, but it's useful, and it's the thing that basically drives the whole process we were just talking about. Okay, so this is just a useful piece of trivia. Okay, can we do this one? What a mess. Okay, so the answer is yes. I'm going to pause to set it up. Okay, so the thing is, you have to put them in descending order like that. And if there's any pieces missing, any terms missing, you have to fill them in with zeros. But you might be concerned because of this 3. It actually isn't a problem, but you also want to put these terms in descending order. And it doesn't have to just be a line. And I told you before, oh, you could just factor out the 3 and all this stuff. It's not necessary. But you can do it, but it's not necessary. And in this case, it's not useful. So let's move ahead and ask the question, how many times does 3x go into 6x to the 4th? There we go. So that's the hardest part of the question. And then we go ahead, 2 times 3 is 6. X times x cubed is x to the 4th. That's great. All right, scribble these guys out. And then we're going to get a subtraction, minus 3x cubed. You don't have to write the whole thing out. Sometimes if you're beginning, you just write the whole rest of the polynomial out. It's not necessary. How many times is x cubed going to minus 3x cubed? There's just a 1 and then x squared. That's all we need. Minus 3x cubed minus x squared. This is kind of cool because this turns out to be even. If it had turned out even, we would still bring down the 9x. If we had not written that, this is where we'd write it. We'd just say plus 9x plus 3. So over here, this is just going to be, we don't need to worry about this piece. It's going to kind of skip around at the top. So the question is, how many times does 9x go into 3x? Well, that's going to just be 3, and then you get 9x plus 3. This thing comes out even. How beautiful. It's kind of nice to put remainder 0 or put a 0 down here. You don't have to do both. But one way or the other, you indicate to me that everything came out nice and even. And so then this is equal to 2x cubed minus x squared plus 3. Ah, yes. So here's a question. What is this root? So we used this language before. So this guy, let's make this top polynomial. Okay, p has a factor of 1 plus 3x. What's the root associated with this factor? And the way you figure that out is you just set it equal to 0 and solve. And the root is negative 1/3. Okay? So let's go down. Let's go to the next thing. There's just one more thing in this video, and that's one that you get to try. So let me pause to write it. Okay, I'm just going to say a little bit about this, which is, this is a little bit of a challenge because you have to put all these pieces together. I will write this here for you. It's going to be on the outside, x squared plus 2x minus 3 And then on the inside, 2x to the fourth plus 4x cubed minus 5x squared plus 3x minus 2. Okay, so I'll let you do this, and I will make the comment here. This actually factors, but you don't need to do that. So if you wished, as a separate exercise, you could take this polynomial and first divide out by the first factor, which is x minus 1, and then divide out by the other factor, which is x plus 3. It's not necessary. You can just do it all at once, and I will let you do that on your own. You do. And I will tell you a hint. The remainder is going to be x plus 1 at the end. Okay, so you work that out on your own, and that'll be the end of this video. If you want to see the answer done out, it's in the notes. And oh, let me just try one more thing. I think this will work. Well, let me pause first. Okay, it kind of works, but I think it would probably work better on your iPad or your Android. If you have the Wolfram Alpha app, it should tell you all the step-by-step directions. But if you just want to check your work on one of these kind of problems, then you can just type this right into Wolfram Alpha like that. It'll give you more information than you want to know about your problem. So it tells you the input, it plots the result. This is just the function x plus 1, but this is probably what we're looking for, the quotient and remainder. So this is really just telling you this was your numerator, this is your denominator, this is your answer, and this is your remainder. So this is the thing you're looking for to check your work. Okay, see you on the next video.